Hello. Welcome to the Lightkeepers Lightcast. This is a podcast about the people who refuse to let the light go off. I am an engineer, and as engineers, we are often trained to ask a question: will it work, and how will it work? But there are some engineers who ask different questions. Should it work that way? And our lightkeeper today is that kind of engineer who has spent her career asking the second question. She looked at our energy systems from the pipeline to the motorways to the power lines, and she asked herself, what is going on with sustainability? And she has discovered something that is rather uncomfortable. The lack of sustainability is not because we had poor engineering, but because we had very good engineering. We were able to build systems that were very reliable, very profitable, and they are generally very good. But they are leading us towards an unsustainable future. And that's why she decided, instead of just writing a research grant or research paper or even carry a banner in protest, she decided to start a whole new discipline. Her discipline is called transition engineering. She believes in engineering and she believes in engineers, and she believes engineers are still able to be part of the solution. But that requires a change of mindset, a change in the education system, and also a change in policy. Our lightkeeper today is Professor Susan Krumdieck, a great friend and a colleague and fellow lightkeeper. My name is Mushtaq Al-Attabi, and with me is Yekemi Otaro. And Ian Houston is unable to join us, and hopefully he'll be able to join us in future episodes. So, Susan, welcome, and thank you very much for agreeing to be our guest today.
Sure. It's great just to have a chance to chat with you anyway.
Absolutely fantastic. So, Susan, you've been a friend, a colleague, and a true inspiration for myself, for our colleagues at Heriot-Watt University, to our students, and also to engineers around the world. But behind all that inspiration and titles and awards, I have a simple question. Who is Susan Krumdieck?
All right. Fundamentally, a small town girl. So grew up in a very small town, under 1,000 people. And so I don't have any illusions about what it's like for people to live together and figure out how to make things work. It's a very isolated community that is deeply affected by drought, by fire, by oil shortages, by costs. Yeah. And yet you don't have a choice but to figure out how to do things yourself. And that then carried on with me, and my interest in engineering was about anthropology and how engineering interplays with the systems that people are living with. So there's words like needs meeting, there's words like from the ground up, there's local strong systems. So there's people who care about this, people at the ground level in their own communities. Very seldom do I meet engineers there. So the question is, if engineers are working for the good of humanity, what does that look like? And the answer is we know what it looks like because we do it all the time. Now, you think, okay, there's 60,000 people today working on how to build a bigger pipeline out of the Middle East. When in fact, the evidence is saying that reducing the flow of oil out of the Middle East is way more profitable than increasing it. The price hike, the biggest profits in years are being shown right now due to reduced supply. So the evidence that it would be possible for corporations to participate in the change of directions that are needed and work for the good of humanity is right in front of us. And I think engineers, you said engineers are part of the solution. Well, the thesis that actually founded transition engineering is that engineers are the solution. And the historical evidence, the way that human systems have changed over time, if you dig into the history, you can see that yes, engineers take us off into a new way of doing things that the whole system hasn't figured out how to actually survive that yet. And then when you get a change to make those systems survivable, it's because it came from the inside. It came from the engineers. So that's the pattern of how to approach work that transition engineers take on. And then they take on learn the processes and do the work and share that with each other. So
this is fascinating, Susan. Every time I speak with you, you talk about change, you talk about care, and you bring engineering back to life. It's almost a reminder why I myself wanted to become an engineer. And you talk about transition, you talk about change. If you could actually tell us a little bit about the size of the challenge from your point of view. We almost have everything that we need to solve the challenge we have, provided that we are willing to care and do that change. Could you just tell us a little bit about that? Because sometimes when people look at the challenge of sustainability or the opportunity of sustainability, people feel like, wow, this is bigger than any one person or any one country or any one organization. Take us through that in light of your transition engineering and frame the size of the challenge for people who are listening to us.
All right. Well, I'm just going to guess that we're at 99% of the people who will hear this podcast can remember the moment when they became aware of challenges that really scared them, that were more than they could handle, and which their first reaction was, well, that can't be right. Somebody must be doing something about that, right? And for me, that was in the 80s with climate change and biodiversity loss and just this whole cascade of disasters that scientists said, we are on this track. This is what's happening. And that feels like a challenge. And it feels really bad. And I think what we really needed to do, and what it has taken me a lot of years to figure out that I could do and that I could teach to other people, is reframing challenge. Right? If you just have a challenge that you personally can't do anything about, then you look for somebody who has a solution and you want to clap that. You want to say, yay, that looks good. Maybe you want to go to work in that. And we have been doing that for the last 30 years. Yeah. And maybe you want to say, look, that's just not my job. That's somebody else's job. Somebody else will take care of it. If the market wants a solution to this, then they'll find it. Don't worry about it. We have technology. We sort of like opt out of that challenge. That's definitely the first thing we can do. Or you might get active, like I'm going to go protest or something. But yeah, 30 years of experience is sort of showing that while sure, all that's possible, it's not the way that a system changes. So looking at whole system change, and as these, again, one of my things I love to do is dig into history where I can find a system change and really study the dynamics of that system change. And of course, the role of engineering in it. And if you reframe challenge to what has to stop, right? So something is driving a system towards this challenge and creating the challenge. So what is it that if it stopped, that challenge now would just be a set of problems, would just be a set of opportunities? And I think that it's the challenge framing that actually quashes the ingenuity that we need. Because what can you do about a challenge? And there's another thing that if you think of it as a challenge, what you're going to find is wicked problems. That challenge is actually a set of paradoxes. Because we must reduce oil production. we're not going to, right? There's these we musts. And no, if you're a realistic person, we're not going to. And I must use my car today to get to work. I must use a plane to get to America. There's no other way. And yet that is harming people of the future. It's causing harms. So these paradoxes of the good thing being a bad thing. Again, if you're caught in a paradox, your experience of that is like facing a challenge that is insurmountable, in that your capacity for ingenuity is suppressed by your emotional response. So the very first thing to do when faced with a challenge is to reframe it. By thinking of it as a set of paradoxes, you can start to unpack and de-escalate your emotional response by looking for facts, looking for things that are both true at the same time, recognizing that, and then reframing as to, okay, but why are we doing all this anyway? What is the actual essential need here? And the whole point of business, the whole point of government is about finding the efficient, profitable, safe ways of meeting needs and providing benefits. And so you can actually reframe into, okay, now I see a thing that I can look for. And again, somewhere in there, something has to shift, something has to stop, something has to start in a different direction. And that then frames up the engineering work. So I think the answer to your question is that a challenge creates an emotional response that dampens down our ability to generate ingenuity. And so we reframe into a way that ingenuity can now be generated, and we can be participating in change.
This is fascinating. So civilization has always depended on energy, and often the more energy we use, the more advanced and more comfortable we are. But as you said, it's at the same time we are maybe depriving the future generations from their right to use that energy while polluting the environment. So it's quite an interesting dilemma or paradox, as you put it. And when we look at the discipline, transition engineering, I heard different origin stories. How did you come up with the idea? I was told the idea of the fire, and how people could have made change and things like that. So if you could actually take us through. I know in hindsight things look different, but where did it all start as an idea, and how do you see it becoming a reality in which we are able to live sustainably as it defined by meeting our own needs currently, while not affecting future generations from actually enjoying the same resources that we have been enjoying? And then, of course, frame all of that from your angle, which is an engineering angle.
Right. Well, I did mention anthropology earlier, and you asked for the origin. Where I grew up in this very small town, we had the Navajo, the Diné homeland, the Hopi homeland, and the Ute Mountain Ute Native American homelands around this area. And just the understanding that maybe the way we say, you said advanced, more advanced, maybe that needed reframing, because those people had the energy they needed. Human beings must cook their food, and they must process materials like make ceramics, and they must process products, like heating up wood to straighten it, for processing. So we are beings of fire. We must have energy. And what I find is I've never found a human civilization that didn't have energy. That isn't a thing. It's not a thing. But what I have found is civilizations that were self-destructive, and civilizations that had the means to adapt to changes that came their way, to adapt to internal changes until they couldn't, that sort of thing. So that environment around me of understanding that there are people who have a different view of what advanced means. And that maybe it's the people whose systems have been working for 10,000 years who are the advanced ones. We are the messy toddlers making a big mess. And if you recast it that way, then what we have to learn is how to actually get to some other way of thinking about where value sits. And so that's why I spent a lot of time researching with Indigenous people about their economic activity. So they understand technology just fine. They know technology probably better than we do. But as in they can fix their own motors. They can fix their own houses, right? But what is their economic decision-making framework? What have they developed that has lasted for thousands of years? And what I found is that balance is always a key. And balance of what you do, that is a new thing that requires resources. If that takes you toward debt, then you consider that and you don't do it, because you look and you say, no, don't want to do that. Because if we get into debt, then what we have to do is pull down our surplus of nature, our surplus of our ability to do things for each other, our ability to have autonomy to do what we choose to do. And so what I found in Indigenous societies that were still working was that they had these balancing mechanisms through value. And the value was in people, place, and bio capacity, and people's capacity to be able to make their own choices and adapt. And when I started applying that model that I was finding from Indigenous societies in South America, in the South Pacific, in the Indian Ocean, in Maldives, and Africa, when I started applying that lens about how you would make decisions, what you would choose to do, then I saw that really our civilization is off on a wild swirl into a bad place of imbalance. We have traded off, debt, rents, consumption against these things that are needed for survival. So this, even reframing how you look at the world from thinking of ourselves as developed and advanced, and not using words like third world, underdeveloped, people who need to develop, and just saying, wait a minute, no matter who we are, we should really find out what people need first before we go engineering a solution. And that's what took me to New Zealand, because in New Zealand, again, you have Indigenous cultures, you have people having to live in an islanded economy. And it was a continuous work to say, how do we figure out what people need? And how do we engineer for that as a whole system project? And out of that, just doing project after project after project, when a community would call me and say, we're having a problem we don't know how to deal with about how to decide about, this big hydro project or a road or we're worried about climate change or whatever, when people would ask me to come and work with them, I would, because I was on the payroll of the people of New Zealand. And because I was lucky to get some brilliant students, and I was really good at material science also, so I could get funding and grants and get to professor by doing that. But you don't get to professor by coming up with new stuff, believe me. So it was in like 2015 when I did a sabbatical 2011, I did a sabbatical in the US, and I shared an office with an eminent professor in sustainable energy who, was a guru to me through 20 years as a mechanical engineer in energy systems, that we got to chatting, and he just, very graciously said, what you are doing is what we've been missing. It's what we've been looking for. And so he invited me to write a chapter for his next textbook, Sustainable Energy, Principles of Sustainable Energy Systems. And that prompted me to do that, to just say, okay, what have we got? And then I worked with him on a course and a big project, and just sort of said, these ways that we've been doing things with my students and with these communities, it's actually processes. It's like what I teach in how to do thermodynamics. Here's an impossible problem, but I will show you the method and the approach to to figuring it out. And so I put that together in a text. And because of being invited by this guru, to be involved in that, then the textbook company took the text. And it was published in 2020. And I then came to Heriot-Watt University by invitation to set up a program around that and to just build it and make it normal. So I think we're very close to that. We're now building the tools that you would use and the management processes, and with colleagues across all disciplines. Because while it's engineering in the world. So we work with people across all disciplines, and that's the arc, I guess. The origin story was just saying, look, if we're going to be here for 1,000 years, we're going to have to figure out something different. We can't keep being this way.
This is very interesting and quite insightful, and I really like that you always take us back to wisdom. So while we have a lot of knowledge, but I think you focus on that notion of wisdom, understanding the deep wisdom that indigenous communities have. And I always found that really deeply impactful, because I think engineering needs to happen within the world and needs to recognize the advancement that has happened, because civilizations that survive for thousands of years, that happens for a reason. It will never happen by accident. Susan, when someone starts something new, whether it's a new discipline or a new whatever, sometimes maybe people won't necessarily warm up to it immediately, and it will not be easy. At least we assume so. Let alone if you are starting something that challenges the way we do things and promising change. And we know people often don't like change, particularly if you talk about changing our behavior so that we reduce the energy that we use. So how did you deal with that at the beginning, before there is a recognition for that work?
Right. Well, I feel like I've been dancing between posts a lot, because if I mention climate change, boom, I'm over in the green camp. And if I mention technology, boom, I'm over in the engineering camp. And if I mention profit, boom, I'm over in the capitalist economics camp. And so again, being dedicated to systems thinking, and then asking, okay, what is that? And finding that, oh, it's a niche. No, I'm not talking about a niche. I'm talking about a way that everyone can do something, right? And so just continuously being willing to bounce around. I know I have been definitely in engineering working on a microstructure of titanium dioxide. Yeah. That's so much more comfortable, just being in your little house, doing your little thing, and not worrying about the larger world. But it's through that, just being willing to find out lots of things in lots of places, and oh my gosh, seeing when somebody's ready to pop me into a place, and just gently, yeah, you know what, I can talk to you about this too. And I can talk to you about that too. And so for me, my own personal ability to navigate in this space is one thing that if I couldn't do that, if I just popped into one of those spaces, then that's how far I can go. Now, the rest of the world, trying to deal with somebody who's doing that, I get it. It's a it's a wild ride, but methodology. Again, not everyone who's watching this podcast will have taken thermodynamics or structures or circuits or controls, but you know that moment when you're looking at a question or you're looking at something and your brain just goes, yeah, I don't know. But start with define the problem, then draw the picture, then balance the forces, then, right? So there's a way through this, and it's the way through complex, messy stuff that I don't know, that's what I think is needed. I missed one more of the things that if you're bouncing around, you might get put into, and that's guruism. Like, I could be a guru, and definitely there are people who are happy with that they could call me and I could give a great speech and they'd have their guru. But yeah, all right. And I think, just thinking like an engineer, it's the method to work through that complexity that's the important thing, which gives me then a focused thing to work on. And that's...
Susan, in this podcast, we talk about these light keepers who found a flame, kept it alive, and then shared the light and reflected it. And your light is fascinating because it's not about something that is needed. It's something that is different. One time you told me about that dream that you have, which is to work with oil companies so that they work on reducing their production year on year, and seeing that being profitable. I think in a way the crisis in the Middle East sort of shed some light on that. We could sell less oil, but sell it for higher price. So if you could, again, without using any mathematics or any thermodynamics, explain how would this happen? That's one. And the other thing is, in order for us or for you to have the audacity to go to oil company that wants to grow the oil production and convince them that there is another way by reducing the utilization of that resource, I think building trust is very important. So what is your approach to building trust? Because as you know, I see collaboration through the collaboration equation, where collaboration equals shared purpose times mutual trust. So two parts to this question is, first, tell us how could we actually be more successful from the capitalist point of view while reducing production without using any mathematics or thermodynamics? And also, what is your approach to building trust with the companies like oil companies and other capitalist outfits where growth is defined only in a certain way?
Right. Chapter 8 of my book goes through this. And it goes through it as using a military strategy framework. Right? So in the military endeavor, if you're the general, there's something you have to do, right? And that's not lose. And you have some objectives that you have to achieve. And you just have to face the reality of the situation and do that. And you know what that does? That military thinking that is instilled into military folks, it gets them through that ingenuity block of facing a challenge. So we thought that looking at that question of how does oil as a business change to where it is actually following RPC 2.6, that it is actually doing that. And we thought, okay, if there's ever a moment for some sort of extreme strategic thinking, it's this one. And so we did that, and we used what's called the matrix game. And the matrix game says, look, you've got to find the competing objectives, right? In a war, there's somebody who's trying to not have you do your thing. And so you find the competing objectives, the people with who are players in this game, and then you find the win and how their behavior, what they will do could be changed into that. And so if you look at the oil industry, they've got 75 years of a business model that has worked, has been profitable, more profitable than just about anything else, really. They've derived enormous power from that. And they've provided really good jobs. That anyone who works in the oil industry, that's the thing they'll tell you. There is no other job like this. The perks, the camaraderie, it's a great thing. So the only way, first of all, if you look at their business and you say, okay, producing less oil, is that at all a possibility in the universe? Is it physically impossible? Well, if you turn around and you look in the past, they have produced less oil every year. And they were profitable in every one of those years. So it isn't the volume that is the problem. It's the business model that believes that increased volume next year is the only thing you can do. Where did that business model come from? From pre-1970, when the price of oil was fixed. The only way to grow is to produce more. That is not true anymore. The price moves around. So the way to grow is to actually produce less so that the price stays high. And you're producing something that there will be a market for forever. And so as a business, to have a plan to wind down your production to a sustainable level, and that's just then calculating your inputs and your returns. And so it's just a different business model.
Now, so Susan, I really want to stop you so that we understand and people who are listening to us understand as well. Are you advocating higher oil prices, and how would that impact people, who are really sometimes barely making ends meet?
Right. Good question. Well, we have a big experiment in that from 2008, 9, 10, 11, 12, 13. And what we saw there was that if everyone agrees that what we're going to do is go back to low price oil through whatever means, then we don't have system change. We just have suffering. And so this matrix game says, okay, the first player is the oil IOC, the oil company, the oil production company. And what we've just shown is that for their business model, it actually makes sense to reduce production. All right, who's the next player? The OECD, like the economy of the world? Because doesn't that collapse the economy? Well, again, we have examples from the past. And what we see is that if why there was economic damage and pain and suffering is because every time the oil price increased and it was not known that it was going to increase, that blows out budgets across the whole economy and you get a recession. So the OECD, looking at the economic supply, demand, everything they know, the way things work, what you know is that if you can plan for that increase, then you just do that and it doesn't destroy the economy. Which people who look at taxes and different things like that, they know that. So this planned production decline and planned price increase, if it was planned and not just an emergency because somebody bombed somebody, then the economy could actually adapt to it. All right, who else is in this game? The IEA. The IEA was set up to make sure that the flow of oil around the world was managed and didn't get embargoed or collapsed. And it requires countries to have stockpiles and reserves, trying to keep the flow going. So would the IEA agree that reducing production and
define
reducing
IEA
that flow,
for us? Sorry, Susan.
Oh, sorry. The International Energy Agency. So it was set up after the 1973 OPEC oil embargo, because that disruption in the flow of oil was a disaster, which it always is, right? But it's less of a disaster now because of the IEA and the
So
treaties
you are
and agreements and
advocating
things.
actually if the prices go higher, and then we extract by design, and we extract more value from the same amount rather than remain dependent on just cheap oil that is being burnt and polluting the world. I think that's why probably you are the guru for
well, it's an unthinkable opportunity is what it represents, that obviously a lower flow of oil around the planet is 100% just possible. It's just engineering. And like I said, it's what's always happened. There's always been lower flow than today. So you would have to have the agreements, though, that some countries wouldn't hoard and leave other countries with nothing. So you would need agreements. You'd need negotiation. You'd need new agreements. Oh, that's what the IEA does. So, okay. And then the final piece of this puzzle, the final player is us, right? Who represents us? Let's say the United Nations, right? They objectively represent everyone and the good of everyone and the planet. Would they be in agreement that the oil companies should reduce supply? The climate guys are going, yeah, that's what we've been saying. And then increase price. And they might be going, yeah, but how's that going to work? And I think that's where the transition engineering comes in. That if you knew the price of oil for your SUV was going to go up, shouldn't there be entry into the market of lots of new something that means I don't need to drive so much? And that's what my research group is working on now, because we've seen that unthinkable opportunity. And there's so many people around the world who are saying, my city isn't, what's going on in my city? It's not nice. Center of Paris, taking out the cars. They're like, this is how you do it. But that's one example, one instance, a planned transition of cities to not needing the fossil fuel and the cars. That looks like a future that I could send my grandkids to.
And Susan, I think you've been thinking about this and talking about it for so long, and I still remember that, once you were telling me that you are so proud of the engineering that oil companies do, and that you would like to convince them to use that ingenuity to apply it to other challenges. It's not only we can only drill and take oil out. They could do so much more with that great engineering. I think this is, in a way, is a proud redefinition of engineering. And maybe my last question to you, briefly, an engineering student or an engineer or someone who is considering engineering may be listening to us. And these mainly young people are having a burden of what's happening in the world, the uncertainty because of the geopolitical situation, the advent of artificial intelligence and others, literally is on their shoulders. And I ask you to say a word to them, and if any one of them wanted to become a transition engineer or specialize in that, what should they do?
Well, if you want to practice a particular profession, there's always a route to that, and that involves training and gaining the certification. And so one of the first things that happened, you were talking about the pathway of transition engineering. There was a very important moment, which was when the Institute of Engineering and Technology, the IET, named me as the prestige lecturer for the year. And so I got to develop a lecture that they took me around to give this lecture, and one of the places was at the IMechE in the Institution for Mechanical Engineers in London, across from Big Ben, and they had a sellout, and the people who came to that said, okay, this has to happen. And they went to work to set up the Global Association for Transition Engineering, a professional organization. A thing I never could have done in my lifetime. So there's a global organization for professionals. And then I was trying to figure out how to teach at different levels these basic competencies and methodologies and stuff so that people could apply transition engineering in their job, whatever it is they're doing. And so I set up teaching, and a New Zealand's first micro credential was for transition engineering, just a CPD course. And so teaching, right? That if we have a discipline, we have power because we have marketability and we have trust. And we have our internal discipline as members of that discipline, and we have that professional oversight. So building a discipline. And then a really big moment was the offer from Harriet Watt to come and set up a transition engineering program at Harriet Watt. And looking at Harriet Watt University's profile, and that they are right in the middle of the industrial development, the industrial might of engineering, especially around oil. And construction and buildings and manufacturing, that this is exactly who our transition engineers are. and so, so building that teaching program, which now has a laboratory component, online global program, which our applications are up 250% this year. So it's only been going since 2023. So that's pretty good. And me putting in a huge amount of work to construct a theory and method and tools, and then a laboratory practice. So a 2-course program that people can do from anywhere, in a flexible way, and then in their dissertation to actually practice that in their job. And I will help them with that and guide them. And then actually later on today, I'm having a meeting with academics to talk about, okay, how would academics build transition engineering into their engineering curriculum? And
of course, Susan, we also worked on getting our students to discover the purpose, articulate their impact statements, and that's probably where it all started. I could talk to you about that all day.
Right. And we intersected on that, and we're like, yeah, put those together.
Absolutely. And I'm going to hand you over to Yekemi to continue with the questions that she has. Over to you, Yekemi.
Thank you, Mushtaq. Susan, I was really interested to hear your journey so far as someone who, I started in the oil and gas industry as a petroleum engineer. So a lot of that was, just very much up my street. You spoke a little bit about, and I'm going to change gears a little bit to the more kind of human emotional side of things. You spoke about people's emotional response to things like, climate change and some of the things that have been happening around fossil fuel dependency. You spoke about, I guess, some of your moments in the 80s where, started hearing about, like the biodiversity laws and so on. What was your own sort of emotional response to that? And what was it that made you almost like take responsibility for making a change or being part of that road towards a change?
Oh my gosh, I'm not really quite sure what it is about me that when I see that something's not as good as it could be or is wrong, that I say, well, I wonder what would make it right. Maybe that's why I went into engineering, that idea of being able to fix things or make things better was just inherent. And like I said, in engineering, and you have to recognize that with our students and when you're practicing engineering, that when you are, when you get the specifications, even if you're just a first year student and you get that homework problem, there's always the moment of fear, like, oh, I don't know. And it's methodology that lets you get through that. So I guess for myself, I was reading an article this morning about something that's really, really bad. You see the temperature diagram thing, and then I think, okay, so yeah, but there's a way to go through this, and I don't have to be the answer. but because I know that things can change. So I guess it's just sort of a silly faith in process and method.
Well, it's what makes you a light keeper, Susan, because not everyone has that response, and you have an innate kind of desire and ability to problem solve, and systems thinking in particular is so holistic and sustainable for the planet. In terms of, I guess, your journey so far as a woman in engineering, so you became the first woman appointed as a full professor, and I remember you saying earlier that you focused on material science for that. So first full professor of engineering at Canterbury in 2014. Can you tell us a little bit about that journey, what that taught you, and maybe how that's impacted the person you are today?
Well, I think I'm lucky that I didn't get the career advancement bug. How do I say this? Like there's a career pathway that is about getting to a higher place. Yeah, like that thing. So I knew that I wanted to get to full professor in order to have the legitimacy to work on these crazy things that I was really curious about. So it was just it was definitely part of the strategy. And then I was really good at the material science and energy systems and, regular engineering stuff that you can publish. And the way I looked at it was that the people were paying me to be a thinker. And that meant that I couldn't stay in a comfort zone. And that I know made it harder. The fact that I'm always like pushing boundaries and bouncing around in that if I had stayed in my lane, I think the journey might have been just, I would say easier, but easier in what sense? I wouldn't have been doing what I wanted to do. So my dad told me, I guess when I was leaving high school, that, look, the one thing I know about you is that you do what you want to do. So you keep with that and you'll be all right. So yeah, I mean, there's a whole construct, like knowing that, well, okay, for 5 years, I was the only woman in the entire College of Engineering. Knowing that and focusing on it wouldn't have been a productive use of my time. Yeah. Doing what I wanted to do. That's what I did. So I guess, if there's anything there, I could definitely tell you stories, but what's the point? Do what you want to do. Figure out what you want to do and do it.
Yeah, for everyone listening or watching, take note of that. Do what you want to do, and definitely follow your passion. If you find a problem that you can get involved in and find a solution, yeah, go for it. So Susan, I love what you said earlier about almost like the different groups you can engage with and you can come in and out of. You talked about the green camp, as you said, and you talked about kind of engineering and tech and the capitalist camp. And I love the word guruism. I've actually written it down because it might come in handy.
Mushtaq's a guru.
So there's been this kind of light following your mission, and it's impacted so many different, I guess, sectors and groups, and even the, I think, global association that you mentioned earlier, which has turned your personal mission into a professional movement, essentially, and then the Island Center for Net Zero in Orkney as well. So, which amplifier has mattered the most for you, and is there anything that the island is teaching you that maybe the mainland can learn from?
All right. I have a really good answer for you on where do I get the energy? Because I could say, well, I have an internal fortitude, I have a light, blah, blah, blah. But you asked me, what is your amplifier that moves things? And it's the students I've had, the community people that I've worked with, the leader of the Green Party who would come to me to ask, tell me about biofuels. I it seems like a good thing, but because I've come to you before, I know you'll tell me the whole story. Right? So it's the people that I've worked with, but especially the students who are looking and who have values and want to express those. That's that's the amplifying element. It's what keeps us in teaching, right, Mushak?
Yeah. And in terms of just coming back to the kind of global association of, is it transition engineering? You called it?
GATE.
So GATE, fantastic. So what role has GATE played so far that you think actually, if that didn't happen, there will be elements of what you've already achieved with, the students and the people that you work with that you wouldn't have achieved otherwise?
Well, if you don't have a professional organization, then you don't have a discipline, right? And again, a thing that I would not have been able to do myself. And the people who form GATE, who are the trustees of GATE, who are continuing to work to make it. Well, they're now working on getting a chartered status in the UK. There's lots of bureaucracy stuff that they work on, but they're professionals. There's not that many academics there. And so having that balance of that they need the academic world to step up and produce the program, right? You have to have a university program to have a discipline. And me saying, well, we need the practitioners who are, they take those things, try them, and feed that back into the profession and start to build the brand and give professionals a place to say, this is what I do. I'm I'm a member of GATE. It means I can do this for you. That's just really important. Yeah. That they exist and that they've stuck with it. GATE was actually, we had the first trustees meeting and elected the first members in 2024. So it's now 12 years. The membership has been growing. It's a transdisciplinary profession. Actually, it has MGATE, so member of GATE, so a practicing engineer. But it also has peer professional membership. So, sociologists or finance people or policy people, just recognizing that system transition is a whole system thing. So yeah, it's a big ambition, but I think the pieces coming together of what a discipline is and what it means to have that discipline. I think we're so close. We've got the pieces and ready to have them sort of fall together is where we're at.
Yeah. It's an exciting journey ahead, it sounds like. And I think the other thing with GATE that I'm thinking is it probably provides some sense of belonging and inclusiveness for people to feel like they're part of something. It's got a name, it's got a community where they can, they can be with like-minded people. So that's great. In terms of, I guess, the climate space in general, I'm sure you've noticed a lot of celebrity voices, people chiming in, performative announcements, and so on. But it seems like you've chosen a quieter kind of approach. You're definitely busy and active in the background, but has that been like a conscious rejection of the spotlight? And do you have any concerns about just kind of getting outshouted, if you like, by these kind of louder voices in a crowded space?
All right. The thing about climate, right? In the 2000s, when I arrived in New Zealand, I knew about climate change and I studied it and I wanted to understand it. And I became quite a pundit, right, in New Zealand for around climate issues. And they would send me around the world to represent New Zealand in that capacity that we're working on sustainability, on how to fight climate change and that. And there was finally, after providing, I think I counted 124, seminars or talks at different community events all around New Zealand and Australia, that there was a community that asked me, they asked me a number of times, they asked me to come and they wanted to do a whole workshop, a whole weekend. And I got my team together, the students, and I just said, look, whatever it is we're doing of me going there and doing another event to raise awareness of climate change, to raise awareness of the risks, to do that thing that climate advocates do, it's not changing anything. I want to design a transition scaping event this weekend. They're going to bring us down there. The whole crew's going. They're putting us up in their houses. We're going to have this weekend event. And whatever it is we do, they are not going to ask me back because they don't need me anymore. They know what to do. They're off. They're building their strong local system so that they're not just being scared of this anymore. They're actually building the future they want. And so we worked on that and we designed it and it worked really well and they never asked me back. But they have a plaque on the wall in their town that has a framed version of the Declaration of Transition Independence that I wrote for them that they could sign their name to, that said, look, we're going to do this thing through the process. We used the transition engineering process. They had, I think it was 7 shift projects that they went off on. All of those are still running. They actually have taken control of their fear and built it into building. And that just really inspired me to say, look, there's enough people scaring people about the climate. There's plenty. I'm going to help people reframe what is an extremely scary thing into how to start where they are and build what needs to be built, and to be honest about that, and to again reframe the challenges into, okay, what are we going to do? And that's more important, that we have transition scaping than that we have more climate alarmism. There's plenty of that and we should be alarmed, but let's actually build transition scaping. Let's do that.
And that brings me to my next question. So it's clear, in my mind, how engineers or people who are from the engineering discipline can get involved and be part of a community and really make change. But for non-engineers, you've spoken about, socialists, maybe anthropologists and so on, how can they carry the light as well? What is that shift project for the non-engineer?
All right. Well, what I'm finding as I do this work, and this special thing, Island Center for Net Zero, was a 4-year opportunity to really do the research on how to do that. What you're talking about, how to engineer whole system change that isn't just about engineering at all. It's about how a whole system reframes its story, reorganizes its economic relationships, builds what it needs, not what it thinks it needs, right? So how in the world do you do that? And I think we're onto it. I think we have the way to do that. And we call it transition scaping in honor of the people of Oamaru who prompted me to think, okay, what are we actually going to do with these people so that they can just get on with their lives? Right. And I think that's, you said it's easy for engineers to get involved. I don't know about that. They get involved in what they know how to get involved in what their discipline sets out for them to do. Like in oil and gas, you get involved in that. And maybe you get involved in the small group in your company that says, look, we need to think about climate change. Or maybe you join the group that's doing the renewable energy or the carbon capture and storage. And then when you've done that for a while, or they've shut it down, you come to me and you take my class and you
okay.
find out the next thing to do.
Okay. No, that's great. Thanks for sharing that. Listen, we spoke earlier about what keeps you going, and you mentioned your students. Is there anything else that keeps you going? Because it must have been decades of challenge and, slow progress, fast progress. Anything else you'd like to add to that before I hand you back to Mushtaq?
All right. What keeps me going? Besides coffee, right? Okay. If you love what you do, that's a good thing. Right? And so transition engineering, part of one of the steps in what we call it systems transition engineering processes. There's these processes that you go through that just generate ingenuity in one way, generate ingenuity in another way, generate ingenuity in another way. And each one of them is a whole systems process. So yeah, oh my gosh, doing that is fun. So engineers, we love to do a thing, right? To get a job done, to get something to work. So it's transition engineering, but it is as fun as engineering. And what keeps me going, there's one of the steps in transition engineering that's about studying the history 1911. In 1911, the system that you're working on, how did that system work? How did their economy work? How did their social interactions work, right? So looking at it with a whole system lens, again, a really fun thing to do that in engineering you don't get to do very often. And a thing you can do with people from other political persuasions, because history is kind of agnostic on your current political issues, with people from, different backgrounds, different genders. Together we can all understand and study history. And then I can give you the cheeky answer. Every time I think, it would be easier to just relax, just go do something else, I think about my grandbabies and the world they've been born into, and just thinking, grandma's got to do something. There's no future in which this grandma's going to say, I got tired, so I thought I'd just go on a cruise. You've got to do what you've got to do. And I'm directly connected to my grandchildren, but I also have the empathy that's needed to not think of future generations as just these sort of others, but as us, and that I have the same responsibility for people who aren't even here yet that I have for people who are paying the price for my lifestyle in Bangladesh, or the people who are being affected by the plastic trash in Maldives, or that we have this sort of newish understanding of our social responsibility for people who aren't just right now here with us. And it has been growing over the last century or so. And when you grow that to people around the world, to the species, to life, and to future humans, then that social responsibility, duty of care, that drives us all, unless you're a sociopath, but it drives us all. And so you can keep a hold of that for your light.
Fantastic. Thank you so much, Susan. I appreciate your
All right.
time. Mushtaq.
Great. Thank you. Susan, that was really touching, the last bit that you spoke about your grandchildren. And my question to you is sort of, and this is really my last question, sort of related, and it requires a very short answer. If you can spark one idea in the minds of young people, or in the mind of even one young person, what would that one idea be?
I'm cycling through them. One idea. I'm going to say learn history. Right? You've got all the pat answers, like believe in yourself, all that stuff. But that effect that studying history and understanding, not history like Bonaparte and the wars and the kings and whatnot, not that one. Maybe the history of engineering, maybe the history of society. Yeah, that study that history, and that is a way to start becoming a systems thinker. And
Fantastic.
It's fun. So yeah.
No, I really like it. Learn history. Well, Susan, founder of the Transition Engineering, keeper of a light that our century so badly needs. Thank you. Thank you for showing us that the answer to unsustainability is not waiting for miracles, is not despair. It's method, its purpose, and it's also the courage to redesign what we have ourselves built so well. Thank you for the light you keep, and thank you for the time you spent with us.
You bet. Thank you for having me.
Thank
Thanks,
you.
Susan.
Thank you.